Let's prove the following. We have to prove that 1 plus cosine theta plus sine theta divided by 1 plus cosine theta minus sine theta, that's equals to cosine theta over 1 minus sine theta. We'll start from the left hand side. So here we have 1 plus cosine theta. So we're going to combine it and make it one term. This is added to the second term, which is sine theta. Divided by, we have 1 plus cosine theta, so let this be a single term, minus the other term, sine theta. Now what we'll do, we'll multiply both the numerator and the denominator with 1 plus cosine theta plus sine theta. So we also have 1 plus cosine theta plus sine theta in the numerator as well. So let's further simplify this. So we get 1 plus cosine theta plus sine theta whole square in the numerator, divided by, so here we can use the identity a minus b times a plus b, that is also a squared, which is 1 plus cosine theta, minus b squared, which is sine theta. Now further simplification is going to give us, so in the numerator we have a plus b whole squared, which will become a squared, which is 1 plus cosine theta squared, plus b squared, that is sine squared theta, plus 2 times ab. So a is 1 plus cosine theta multiplied to b, which is sine theta, whole divided by, now let's expand it. We're going to get 1 plus 2 times cosine theta plus cosine squared theta minus sine squared theta. Right. Now further simplification is going to give us, so we're going to expand 1 plus cosine theta whole squared, so 1 plus 2 times cosine theta plus cosine squared theta plus sine squared theta plus 2 sine theta plus 2 times sine theta times cosine theta whole divided by 1 plus 2 cosine theta plus cosine squared theta minus, now here we have sine squared theta. We're going to use the standard identity, that's sine squared theta plus cosine squared theta, so that's equals to 1. So that means we can represent sine squared theta as 1 minus cosine squared theta. So that means in the new denominator, we're going to have negative of 1 minus cosine squared theta. Now, we can also replace this cosine squared theta plus sine squared theta as equals to 1. So therefore, we're now going to get, so here we have a 1. 1 plus 1 is going to give us 2. So we have 2 plus 2 cosine theta plus 2 sine theta plus 2 times sine theta times cosine theta whole divided by 1 plus 2 cosine theta plus cosine squared theta minus 1 plus cosine squared theta. Now, what we can do, we can combine the first and the second term by taking 2 as the common factor. So we're 2 times 1 plus cosine theta whole plus, so we have the third and the fourth term. Here we can take 2 sine theta as the common factor. So we have 2 sine theta multiplied to 1 plus cosine theta divided by, so here positive 1 and negative 1 will get cancelled out, and this leaves us with 2 times cosine theta plus 2 times cosine squared theta. Now we'll do further simplification. So in the numerator, we're going to take 1 plus cosine theta as the common factor. So this will get multiplied to 2 plus 2 cosine theta whole divided by, so in the denominator, if we take 2 as the common factor, 2 cosine theta as the common factor, so we have 2 cosine theta multiplied to 1 plus cosine theta. So 1 plus cosine theta gets cancelled out or factored out from the numerator and the denominator. We can also factor out the 1 from the numerator and the denominator. So we're going to get 1 plus sine theta divided by cosine theta. Now this is not exactly the expression on the right hand side. So on the right hand side, we have to show that in the numerator we have cosine theta, whereas in the denominator we have 1 minus sine theta. So let's do one thing. Let's multiply both numerator and the denominator with 1 minus sine theta. So we have this 1 minus sine theta now in the denominator portion. So combining 1 plus sine theta with 1 minus sine theta, we're going to get 1 minus sine squared theta whole divided by cosine theta times 1 minus sine theta. Now since we know that the identity sine squared theta plus cosine squared theta, that's 1. So 1 minus sine squared theta will be cosine squared theta divided by cosine theta times 1 minus sine theta. So we can factor out 1 cosine theta from the numerator and the denominator, And our final expression will be cosine theta divided by 1 minus sine theta, which is the expression on the right hand side. And we have successfully shown that the left hand side of a given trigonometric expression is equals to the right hand side, hence proved.